right, hi. My name is Roberto Capodieci. I eat blockchain for breakfast, a lot of it, as you can see. So I would like to, David did a good job to explain blockchain, right? Bitcoin blockchain particularly. The one thing I want to underline about blockchain and why it's powerful and decentralized is because to shut it down, being made of many nodes, it would take a coordinated operation to shut down them all at the same time. And this is impossible because it's distributed around the world. And you shut one down and 3 more comes up. As you know, with mosquito, you kill one, 3 more comes to you. They are the same thing, right? So this may sound a little scary also because it's a living organism that we cannot stop, right? And there are many kinds of blockchain. Sir here was asking a correct thing, is value information that moves. For what concerns IoT, besides the good idea that an IoT device can pay for its own repairs or services, the value is to send information through the blockchain. But many can think, why? There is already internet. We use the internet, IoT devices are connected to the internet, they send information to each other, they have an IP address. Why would I need the blockchain rather than just using the internet, right? Well, blockchain, I go one step down, trying to keep it the easy way as possible. It's made by 3 main elements. Oh, just to understand, there is not just one blockchain in the planet. There are hundreds of thousands. Everybody can start one any day, right? So there is a database system, which is replicated by all the nodes. Mostly should have the same information in every node. There is a peer-to-peer network for data distribution, so data is sent all over the network. And then it's based on cryptography, the private public key and the other cryptography system that David was mentioning, which is a very important part to understand why IoT will need the blockchain rather than just the open internet. So let's look at these things one by one. The database, everybody knows what it is, right? So every node has a database where you store the data that is sent and distributed. And this data is composed by some metadata that's gonna always be there and some payload of the transaction that can be also removed. Some people think, well, Bitcoin is only a financial transaction. But IoT is going to send maybe a CCTV camera shot data in real time collected. It's going to bloat the blockchain, is going to explode. But that's not the case because you can only send the data to the nodes that are interested about it and keep the metadata as a common information around all the databases. Then the peer-to-peer network, for those that don't know, is a way to send an information around. It works like gossip. The first computer tells to the computer around them, hey, this is happening, I said this is the things. They say to the other one. I'm sure they also say, hey, I told you, but don't tell anybody. Yeah? So the information goes around and reach all the network. So, and last, the most complex part is cryptography. And this is the mathematical magic, because cryptography is not software. Cryptography is a mathematical algorithm, which means that can be implemented in any way we want. It can be in a JavaScript on the browser, it can be in C compiled application, it can be embedded in a piece of hardware in the device. It doesn't really matter how it's implemented, because if it doesn't respect the algorithm, it doesn't work. And the security is not on the capacity of a piece of software, but is on the mathematics. And this is very, very, very important. To give an example, today when we connect to a database, to a website, or to an IoT device, we send a username and password. There is a piece of software in the device, in the server, that evaluate our username and password and check if these are good to give us access to data. So the data is all in clear behind. And this piece of software decides what we can see and how we interact with this data. Which means that if I'm a good hacker, I can break to this piece of software and access all the data anyway. Using cryptography, I can encrypt data, and the access to the data is given only by my capacity to decrypt it. And I can authenticate myself, not thanks to a piece of software there, but digitally sign with a mathematical algorithm my identity and sending it over. So this is a huge shift on security level. So today, for example, I can break in somebody's house router, pretend to be the thermostat, and send it to the central heating unit to bring the temperature to tropical level. In Singapore, it will be useless, but you know. Now, If the central heating system was expecting a digitally signed information from a thermostat, it wouldn't care about my attempt to raise the temperature unless I can break into the thermostat hardware and discover the private key that is saved there. Even if I replace thermostat, I need to re-register the new public key with the central unit. So this is why blockchain embed this security mechanism to bring to IoT high security in an open network in a way that is not need to be protected by username, password, software that is not developed properly by, in IoT is interesting because we have electronic engineers, they need to trust software engineers. Usually we don't understand each other very well, and then some mess happens. So using digital signature, this problem is solved. All right, that pretty much. I don't want to take more time away from the panel. I had another 27 pages to read to you. I'm not going to do it. And I'm going to sit and start answering questions. Thank you very much.
Thank you very much, Roberto. Now, we should have some, yes, we're using pigeonhole.at. There we go. These are the instructions for submitting questions. This is an online system. You log in there, put the password in. I think you probably have to select this session, and then you type a question in, and it'll show up on this iPad, which I'm holding in front of me here. And you can also, you can see all of the questions that have been submitted, and you can vote as well. So that's how we're going to get questions submitted and voted on and so on. I'm going to put the questions to these guys. Just clearly we don't have many questions yet because I've just given you those instructions. So to kick off, I'm just going to go straight to the core. Why do we need blockchain in IoT?
Well, I just explained.
Well, no, what you've done is you've explained lots of things you can do with blockchain. You haven't said why we need it.
I think it really raised the level of security. That's the core part. Besides saving data to offer analytics or... this microphone is not working well, but... Hello? Okay. So besides offering audit trail that are secure and safe, beside offering the possibility to access information anytime, is the digital signature aspect, which I believe to be the core important aspect of using blockchain with IoT. If I had the project to develop, I wouldn't have any doubt in using it. Can be in a private single node blockchain at this point, but you already raised the level of security compared to just using the open internet.
Yeah, I mean, I look at the value of the overall network, especially when you talk about like public blockchains. I mean, we've seen throughout history, especially on the internet, that open blockchains tend to be more valuable overall. And the more people that use them for different purposes, the more valuable it becomes for everyone who uses it. I see IoT as another part of this ecosystem, that if we can start connecting IoT devices to these public blockchains, putting some of that information that they want to be public onto these public blockchains, whether it be sensor information or different APIs that are now being provided by the government, for example, data patterns or temperature patterns or whatever it is. If that can be put into the public domain for the public good, you now have a historical record of these things which can't be changed over time. So if today the government says, well, the PSI rating is 87. You can't go back later on and look back and say, well, it was only 57. There's a record of it happening at some point in time. So I think that this is a real value of blockchains, is that historical record of transactions, as well as other devices being able to read off of this information and make use and value out of it.
Sorry, there are a couple of more interesting aspects about blockchain for IoT. A device can sell information. So all other devices or people that want to read for example, the level of the pollution in the air can actually pay a small token which helps to support the device electricity bill, for example, and so monetizing out of the service of the IoT directly. Another aspect will be to create a diary of ownership data. If is something attached to something that can be sold to people, you can see all the track of past ownership or damages and repairs, etc., because giving digital identity to the device gives also the possibility to record history for the device. Yeah?
Okay, thank you. I mean, so it's a ledger of record. It's immutable. It can't be changed. It can't be hacked, etc. That, I mean, conceptually, that's a very useful thing. What is it? What is it that's? What are the components of this? What are the nodes? What's being transmitted from who to, or from what to what and to who? Because you've mentioned some kind of closed network blockchains.
I mean, as far as the different blockchains, so you have the public blockchains and then you have private blockchains. Public blockchains have certain conditions put upon them. So many bytes can be transmitted in the payload area. In the example of Bitcoin, it was 40 bytes and they raised it to 80 bytes. In Ethereum, I don't know if there's a limit, but there's a limit as far as how much you can pay for that storage. NXT may have certain limits. 45 kilobytes. So that's quite large. But if you created your own private version of one of these blockchains, then you can set it to do whatever you want as far as storage.
Furthermore, blockchain are public, private, permissioned, or permissionless. So a permission blockchain means that there is, in effect, a central authority to decide what account can post information or not. It can be public and permissioned. In the case of IoT, for example, in the city, all the devices can post data in the blockchain. Everybody can keep a node at home to do analytics, but they cannot post data. So you can limit who the data can be sent from, and it is removing also the need of a cryptocurrency inside to post the data, because you control who can post. But at the same time, you give everybody the access to a database which is in local storage, and allow very strong analytical possibilities, because can be queried very much.
Okay, thank you. And I'm going to go to a question from the audience here, which is, with all the mathematical computations, will blockchain be too computationally heavy for the IoT? So I guess, I guess if we're in a situation, a more centralized, controlled infrastructure, you might have a single record which is backed up. Whereas what the blockchain does is blasts that record out across countless, and the more the better, I would assume, servers, and it just replicates data. And the more that data gets replicated with more messages and more devices, you just get an exponential effect. How do you deal with that?
I think that the question was more addressed to the proof of work that Bitcoin has, much than the data storage. Meaning that Bitcoin has been the icebreaker, has been the first use of blockchain, and it's been done using a system that requires a lot of processing in order to create a new block, to create a new block of data. There are supercomputer processing this. It doesn't have to be like that. For example, Ethereum now is moving what is called proof of stake, or NXT has been the first crypto platform using proof of stake, which means that you can run it really in a cell phone, and the mining, which is called mining, or forging in case of NXT, can happen without that.
May I sort of Roberto a question, because he developed a hardware wallet that actually signs transactions. So perhaps you could explain the kind of minimum hardware necessity in order to sign a transaction.
Yes, correct. There is a difference between creating a block on the blockchain and signing a transaction that goes into this block. So the mathematical operation to digitally sign a transaction is minimum. Can be run by a small, everybody has an OTP device, the token for the bank. All those tokens have the possibility to do digital signature as well. So that's not really a power consumption. But
you have two issues there, I think. Just expanding the question from the audience, if you think about the long tail of the IoT, so firstly you've got the vast amount of numbers and the multitude of things connecting to things, and what that does is it drives the overall scale of the central storage of the blockchains, which are replicated in many places. So you're driving up that storage. And the other thing you get in the IoT is the long tail of devices, and I will give the example of something like an LPWA connectivity technology, which are there specifically to connect devices which have extremely low compute power and would want batteries that last for 10 years. These devices cannot execute those kind of transactions you're talking about. So you've got, it's a consequence of numbers and long tail. So how can it still suitable?
the device doesn't have to be a node of the blockchain. Yeah. So when we have a wallet to send Bitcoin, we don't have a Bitcoin node in our wallet. The wallet is simply the digital signature and submission of the peer-to-peer network. So which doesn't require any computational power. The nodes, they conserve the data, then they can become, based on the need of the blockchain, they maybe need to be bigger or more powerful or not. That another thing is that the Bitcoin blockchain needs to keep record from the beginning of the history to day. But for example, information that is necessary only for 1 week or 1 month or 1 year can be pruned, can be deleted in a blockchain that doesn't have a financial aspect for which I need to keep a ledger of transactions. So I can set all the nodes to automatically delete old records because I'm not interested. I only keep the key of the tail of the chain to make it valid, but the rest of the payload of the transaction can be eliminated. So I can store 100 years of data easily in not a big computer.
So this is effectively a blockchain implemented within what I would term a subnet of things. It's a group of parties which agree and potentially prune that. So in certain circumstances, what we're doing is we're deleting the immutable record aspects of a blockchain, for purposes of use of the subnet of things. So we're effectively de-scoping it.
Yes, depends on the need. Everything can be made, right? So what is important to leave inside the fingerprint of the content. If later in time I want to validate it as happened in a certain time, a certain moment, yeah.
Yeah, I think as long as you store the hash of what happened, as Roberto was saying, the fingerprint of what happened, you can reconstruct it and you can prove that that thing actually happened at that point in time. You don't need the inputs to necessarily get the output.
No, you don't. But what that results in is an ever-growing series of blockchains which have to be stored centrally somewhere in multiple devices because that's how it works, and that drives up, storage capacity.
Yeah, there is a Moore's law that says the storage doubles for the same price every year, right? So I think that if YouTube can store all the video that people is uploading every minute, some transactional data are not a big deal. But that's, depends on the quantity of data.
It does. Hello, it does. Is this not
Test.
Sorry, microphone's just stopped working. Maybe it's a hint. So that actually brings me to the next question, which is who pays? Because the thing with blockchain or Bitcoin is you mint new coins, and that's how you get paid. Concept doesn't carry to IoT.
Well, it could. I mean, there's no rule that says that you can't have seigniorage in a system like an IoT system, especially when the data has value itself and you're creating a new token to buy that data that's then being traded in the open market. So for example, let's say you had, and a great example of this is MadeSafe, which is data storage. So we all have hard drives sitting around, they're not really doing anything. You plug those into the internet, you get rewarded with a MadeSafe token for sharing that storage, and you can then sell that to someone else for another cryptocurrency of value, let's say a Sing dollar coin or Bitcoin or whatever it is, who then use that token to purchase space on those devices. So it becomes a very virtuous cycle of usage in that way.
Yes. Yes. Has that not tied the loose and abstract peer-to-peer concept of blockchain into something which is governed by an economic model, i.e., who pays and needing to pay, and so effectively what you have is the hierarchy of a traditional IT system replicated on a financial and contractual basis in order to fund something which is a peer-to-peer. So you've taken out another leg of what blockchain is effectively.
I think if you want to have distributed ledgers that are irrevocable, you need to have some sort of financial incentive for people to use them and to store this data. So the financial incentive of the institution that's running a blockchain may be different than the financial incentive of somebody running a public blockchain. So if we do a permission blockchain, we have a financial incentive to store this data. We want to keep copies of it. We want to keep records of it.
Yeah, matter of fact, with the permission blockchain, you can even charge a monthly subscription to the people that want to have the permission, right? And then with the money redistributed to the nodes without going through an internal cryptocurrency.
Okay.
Someone's got to pay for it at some point.
Exactly. So I'm going to go to another question from the audience. IoT is often real time. Blockchain is a transactional technology. How does blockchain deal with real time data, especially high bandwidth data?
Well, that's a very good question because, in fact, blockchain store and secure data in intervals. So how long it's going to take to create a new block? That's what makes the difference. But data is broadcast in real time in peer-to-peer. That's not a flow of a video, for example. If it's a CCTV broadcasting video, that's something that goes on the side that cannot really go through the blockchain. So, in fact, it's not valid for all the cases. So yes, I do believe that there are information that it may be worth to save in the blockchain. A stream of data may be not worth to save it in the blockchain, but maybe it can be encrypted and the decryption key be saved in the blockchain and sold for money, for example.
Yeah, I think at this point it's better for snapshots of things. Just as events happen, just a snapshot in a visual sense.
Thank you. And I'm going to go to another question from the audience. Can you elaborate on implementation of blockchain with e-commerce, especially on IoT like Amazon Dash buttons? I guess that's a sweet spot.
Let me see if I can understand the question. So you're talking about device-to-device M2M payments, right?
I think it's supporting the e-commerce transaction.
Well, and XT itself has a marketplace with all an e-commerce implemented in the centralized manner. So it means that there is no central server and there is all the procedure of purchasing goods or services, then confirming the receipt, claiming for a discount or refunds, and it's all managed in the blockchain. You connect the service being sourced by an IoT, because as we said, any digital identity can be a human, can be as much as a device. Then you have the system already set, already exists. Yeah.
Yeah, I think if we take the Amazon Dash button as an example, so we're running short on milk. The refrigerator has a digital wallet on it. It creates a smart contract with a supermarket that has a smart contract with a logistics company. So it creates a contract with the supermarket who has a contract with the logistics company who has comes back to you with the milk the day later. And when your robot at the door signs for the milk, it completes the transactions, paying everyone along the chain. So I think that, it would work out well.
Thank you. Thank you. Another question from the audience. IPv6 claim that there are embeds with very high level of security. How does blockchain compare with this industry standard, and can the two work together, or is one replacing the other?
It's IPv6?
IPv6.
Well, IPv6 is just a different protocol to transfer data. There's not much overlapping with blockchain. So every blockchain system can be run through a normal IPv4, IPv6, through Tor, through a local network. At the end of the day, the networking aspect is now a core part of it. Yeah.
So blockchain is payload data, and IPv6 is network infrastructure.
Yeah, it's a layer above the networking, correct. So
they're
doesn't really matter, yeah.
Basically. Okay, thank you. Sorry, one short on the microphones. One of the promises of IoT is large-scale machine learning. Is this something that is difficult to achieve with blockchain, or does blockchain simplify that?
Yeah. That's for sure helps, right? Well, having a common repository of many devices data input offers a huge insight on data, and to consequently help. Smart contracts that David explained quite well are not really artificial intelligence, but can create a level of automation and automatic consequence to almost mimic artificial intelligence. So more data available, better decision can be taken. So I do believe the blockchain has the potential to help this aspect. Yeah.
Yeah, I mean, the global computing idea, it's basically a really stupid, dumb computer system that's extremely secure. So you don't get the AI ability of it. You would need external systems sitting on top of it and analyzing the data to make it valuable. I don't see it as being an AI usage.
Okay, thank you. But is there a potential issue around the fact, or my understanding is that transactions and information are stored within the blockchain in an encrypted fashion, so somehow you'd need to decrypt that.
That is a matter of privacy, so information can be also left in clear for everybody to see. It depends really on the decision of the poster of the information.
So it's back to the subnet of things concept, effectively.
But even with that, I think, well, there's always the potential to do some analytics on the flow, the metadata coming in and out. You can probably, I used to be able to tell which, so I run one of the Bitcoin ATMs. One of my competitors here had a Bitcoin ATM. I could actually see their transaction value or volume going in and out. So because they weren't changing it properly. So there's always the ability to do some additional tracking on it.
Okay. Next question. Can blockchain be used to authenticate, i.e. uniquely identify an IoT endpoint, e.g. a sensor?
Yes, absolutely.
Yeah.
In the most secure way as possible.
Yeah, I mean, unless somebody somehow hacks the device and gets their key.
Then that's the trouble, yes.
Yeah.
Okay.
Yeah, you always rely on the quality of the coding used to do the device, right?
Okay, and then what is it that we wouldn't be able to do if we didn't have blockchain in the IoT? So looking at this the reverse way around. I guess there's a grading on that question. So there's some things we fundamentally wouldn't be able to do. There's some things we wouldn't be able to do as efficiently. And then there's some stuff which is basically on impact.
I guess that everything can be done anyway without blockchain, but you have less security and centralization. So you will need a central server with some application to provide the additional things that you want, for example, selling the data, do the marketplace of the information, or request other things. With the blockchain, this can be decentralized and much more secure, that I will say.
Yeah, I think the addition of the tokens, as Roberto was saying, the addition of putting money into the same system that you have data being exchanged provides something that isn't available.
Yeah, you can do it without blockchain anyways, though, but it will be less secure, though, right? Independent on a centralized server.
Yeah.
Okay, thank you. And then there's another question relating to monetization. So how will the virtual currency in the blockchain for IoT be eventually monetized to real currency? And I guess that's talking about monetizing the data rather than assuming that it's actually a currency.
First off, we need to kind of define what currency is. If I give Roberto a stock tip, that could be very valuable as information and as currency between us.
Exactly, yeah.
There is always a market for things, so people need to have something and pay for it, right? So in a way or another. I mean, Bitcoin itself, even the banknotes I have in my pocket are representative of an idea, not much of a value, intrinsic value, right? So unless it's a coin.
Yeah, I think it becoming real currency, whether it be data or the token itself, is just a matter of the market deciding that it's real currency.
Okay, and presumably, what would be the infrastructure by which that came about? Presumably, it's back to the subnets of things concepts and the stakeholders in a particular blockchain deciding what it is that can be monetized and what can't be monetized. So the blockchain becomes something that supports a commercial transaction rather than be something that is free living in the outside world and floating around the internet and can be picked up and monetized by people as they come across it. It's a more managed process supported by a blockchain.
It depends on the scope. If it's a university project that is not for money, it can be a very good value there too. At the end of the day, is always determined by the need of the project that is implemented, I guess.
Okay. So it could be some data is made available for free, but
I mean, a very simple example of this is like degrees or certificates from universities, and I know they have a problem here where people have fake degrees or they provide fake information to employers, especially government agencies. But if you were to graduate a university, you could have your information be created in a secure way into a hash, and it can only be recreated if you know the specifics of that information when you go to your employer. You could therefore verify that, yes, that information when it was created was true. So that doesn't necessarily have a monetary value in currency, but it certainly has a value to the employer and as well as the employee and the university as well.
Yeah, for a simple comparison, without the distributed ledger, but the chain of block of data, even the log of a server could be chained file by file with the mechanics of the blockchain, making it super safe. So the applications are unlimited. Even internally to a single device, IoT device, data can be stored secure using cryptography. Then they can be applied to a blockchain in the moment that is connected to a blockchain. So blockchain is always made by many different elements that they don't always have to work all together, right?
Yeah, and I think it's up to the companies and the consortiums that build up around it what data they want to allow to move from this blockchain to another blockchain and be sold for real currency if that's what they want.
Okay, thank you. And then another question: which aspects of IoT will blockchain impact the most? And I guess adding some extra thoughts to that. You mentioned blockchain in the context of employee authorization. I can see within employees coming into a building, that's something that the blockchain could be very relevant to. In terms of applying blockchain to individual smart meters within the smart metering estate in Italy, is blockchain so relevant there? Which are the areas that are most relevant and least relevant for blockchain?
Roberto can talk about a bit of corruption in Italy and how it can prevent.
I will see a blockchain for political people that promise during the pre-election campaign and save the promises in the blockchain to be then later proved wrong. Anyway, I do things that wherever it doesn't hurt, why not? And wherever there is a need of digital identity and digital signatures for data, blockchain has this element as the top of its core. So it comes out to be good. We had solution to be implemented where they had single node blockchain. So it's not even a distributed. It's a single server, but is like installing a database of any other kind with specific characteristics which are good,
Okay, and who is it? Is there anyone who's doing blockchain at the moment? Who's implemented IoT blockchain solutions?
I think right now everything seems to be a POC stage. I don't know any free roaming IoT setups yet.
Yeah, I heard a lot of beautiful ideas with smart contract that do everything, but the real implementation on blockchain really POC. There is a lot of experimentation done at this moment. Yes.
Okay. Well, what are some of the interesting POCs? I mean, you've mentioned the IBM proof of concept. I'm sure there are many others.
Well, for example, myself, my company, we're doing trade finance documentations managed on the blockchain. So all documents they need to be approved, confirmed, sent all around the world. So we don't do remittance payment of financial things, just document management. So letting people chat, approve and confirm documents, bundle documents, all using the blockchain. There is no IoT actually involved, except in a certain way. There are those fax modem that receive fax, which I thought they didn't exist anymore, but they still be used. So when they arrive at the bank, every fax image is given digital identity so that people can point to it and then discuss about it or approve so that they are digitally valid.
I just had a meeting earlier this morning with someone from the insurance industry. We were discussing potentially using blockchain combined with something like a Fitbit where it monitors what you're doing, your activities, and if you do enough activities, they would reward you with a token which then could be used for various rewards, either reduced insurance, or you could trade it for somebody else for value, or you could use it at the health food store or whatever you want. So I think once you start putting all these things together, once you have the convergence of IoT, tokenization, the ability to share the data, the ability to monetize the data, it really creates some interesting opportunities.
Okay. And just in terms of efficiency of storage and efficiency of, I guess, network asset usage, in a single node implementation of blockchain versus a more traditional database, which is effectively a reasonable comparison, I think, which is more efficient in terms of space utilization, disk space, memory space?
In blockchain, data cannot be changed, right? So amends to information are another layer of data breach, and that's pretty much the database used for NXT, for example, is SQL. So it's just a regular database. It's the way the data is handled in the database that make the difference. Not much the database. Database can be anything. It can be an Oracle machine, where it's no problem.
So it could be significantly, you could consume significantly more space and more resource in return for providing that historical record.
It depends on the need, because if you think about it, where law require audit trail of every operation done, even in a regular database, every modification of a record has to be recorded anyway. So in those cases, it will just actually take less, because in the other one there is a replicated data at any moment. So it all depends on how is managed. But I think there is a huge myth about huge data in blockchain, which is not so real. I mean, it's minimal. It's not as big as people sometimes think. That's a fact. Yeah.
Okay. Thank you. I think we're running out of questions. Questions to the audience. Anyone else have any questions who hasn't gone through this online system? Oh.
Yeah, that's something that is actually being dealt with. So they're talking about sharding it. So maybe 100 nodes store the first 100 gigabytes of data, and then the next 100 store the next 100 gigabytes, and it's distributed enough that it's still secure. You don't need full 6,000 nodes keeping every record. You only need 100 nodes or 1,000 nodes keeping every record, and then maybe another 5,000 keeping pieces of the record for it to be secure. So yeah.
Do you actually take into account the growth, let's say, given all the application, also Moore's law, let's say, in the back to handle that?
Yeah, so Moore's law is definitely a big plus for blockchain storage, but the growth of it is going quicker than Moore's law, so there's definitely solutions that need to be found for that. They are pruning certain records, though, reducing the amount of data that's needed to be stored as well. You don't need to store all the information of a transaction. You only need to store certain pieces of it to know that it actually occurred.
But do you actually mean it, but is then still all the data there? I mean, you say you can prune stuff, right?
Mm-hmm.
But then still everything that's relevant, you mean, that relates to the transaction is there? Or
in NXT, for example, data expires, so the payload of the transaction is automatically deleted unless you pay more to keep it there longer, and this automatically solves a huge part of the problem. There are other solutions that are implemented, for example, creating a special block with the balance of all the accounts on once, wait, for example, a month that all the node agreed that it was good, and then remove all the past because there was no interest. But this is really a decision of the node holder, because I can switch the setting on my node and say just don't prune data, don't delete data. I do training for law enforcement where they need to do investigation on blockchain. And when they set up their own local node in the law enforcement agency, naturally they leave all the data forever, because they can invest in bigger hard drives, and they want to see historical information that maybe other people try to delete. Yeah.
okay, thanks.
Hi.
Historical mapping of the truthfulness of the transaction.
Yes.
That's the core idea.
Yeah, I mean, we can. Yeah, it can go very close to one of the core aspects of blockchain, I think.
Yeah. Quick question on the blockchain ecosystem, right? Obviously, it's open source, but are you seeing fragmentation of ideologies itself? Is that a danger to blockchain?
I think any open source project is going to fragment into different incentives. So as far as Bitcoin and Ethereum and NXT, these are public blockchains. People understand that these need to stay public, and people devote a certain amount of their time and resources to that. That being said, there's also groups of people kind of creating their own private versions of them that have different incentives. You might earn a lot more working for a bank building a blockchain than you would helping to support a public blockchain. But I think there are certain ideological grounds for doing both of those.
And there are a lot of very wealthy people throwing a lot of money on public blockchain to get them going and get the developer doing new things. So I mean, it's very balanced, I think. Yes.
It's a hard answer. It's a hard thing to answer. We don't know how it's going to turn out.
Yeah, just
Honestly.
one thing is important, because everybody tends to end up thinking about Bitcoin, which has some technical aspect that makes it very difficult to be really distributed, really. So I think Bitcoin is fantastic, but there are much newer technologies. One day Bitcoin is going to transact to a new platform, I think, eventually. But things are very different. Bitcoin is unfortunately very limited by the technical difficulties that implies. Yeah.
But it's also the most secure and highest volume cryptocurrency.
But naturally, it's the first. Yes, absolutely.
Okay, do we have any other questions? We've only got just over a minute left, so if there are no other questions, we've finished almost exactly on time. Thank you very much, guys.
Thank you.
Thank you.
Thank you.